Bismillahirrahmanirrahim and Assalamu alaikum. Today we will discuss another property of liquid which is called vapor pressure. Let's take a liquid in a closed container. The molecule of liquid having a specific kinetic energy, those molecules which are at the surface of the liquid will have greater kinetic energy, and hence it will overcome the intermolecular forces among their molecules and change into vapors. This process is called evaporation. As the vapors move in all possible direction, when some molecule reach to the surface of the liquid again, they are captured by the liquid molecules, and hence it lower its energy and again it change into liquid. So this process is called condensation. Initially the rate of evaporation is high while the rate of condensation is low. A time reach when the rate of evaporation become equal to the rate of condensation. At that time, the vapors of liquid exert pressure on the surface of liquid. Such pressure is said to be the vapor pressure of liquid. Let's suppose we have any liquid. So when it changes into vapors, then it is called evaporation. Initially, the rate of evaporation is high. The molecule of liquid change back into the molecules of vapors change back into liquid. It is said to be the condensation. So when the rate of evaporation become equal to the rate of condensation, then the pressure exerted by the liquid is called vapor pressure. Now there are some factors which are responsible for the vapor pressure of a liquid. Remember that vapor pressure of liquid does not depend upon the amount of liquid or surface area of liquid, but it depends upon the four factors. The first factor is the nature of liquid. A polar liquid has lower vapor pressure than a non-polar liquid. We know that the vapor pressure of liquid depend upon the nature of liquid. Polar liquid have high boiling point and exert little vapor pressure at a given temperature. Let's suppose we take water and acetone at same temperature. Both are kept at 30 degrees centigrade. In water there is hydrogen bonding, while in acetone there is dipole-dipole forces. As hydrogen bonding is stronger than dipole-dipole forces, that is why water will have less vapor pressure as compared to acetone. Remember that if a liquid is more volatile, then it will have more number of vapors at a particular temperature. Greater the number of vapors, greater the pressure exerted by them. Water is a polar molecule. Its evaporation capability is less because of its strong intermolecular forces. So if we keep both acetone and water at same temperature, then the number of water vapors will be less than that of the number of vapors of acetone. That is why vapors will exert less pressure as compared to acetone. So intermolecular forces are responsible for the vapor pressure. If the intermolecular forces are strong, then the vapor pressure of liquid is low. Let's say we have two liquids, alcohol and water. Both alcohol and water have hydrogen bonding present in it, but water can make two hydrogen bonding per molecule while alcohol can make one hydrogen bonding per molecule. So obviously in water the intermolecular forces are strong, so at a given temperature water produce less vapor as compared to alcohol. That is why vapors will exert less pressure as compared to alcohol. As in other words, we say that the vapor pressure of water will be lesser than that of alcohol. The second point is the size of molecule. Let's take two different compound having same nature. Let's say both the molecules are polar or both the molecules are non-polar. The nature remains the same. Then we have to look at the size of molecule. If the size of molecule is bigger, then the vapor pressure will be will be lesser. So greater the size of molecule, stronger will be the intermolecular forces, and hence lesser will be the vapor pressure. So if we look at the relationship, the size of molecule is inversely proportional to vapor pressure. If the size of molecule is bigger, it will have strong intermolecular forces. At a given temperature, it will have less vapor and hence it will exert less pressure, so vapor pressure will decrease. Let's suppose we have hydrocarbons, two different hydrocarbons. The size of the molecule C10H22 is bigger than C5H12. Therefore, among decane C10H22, the intermolecular forces are strong. They will have less number of vapors at a given temperature. Therefore, they will exert less pressure, and we say that its vapor pressure is low. So, for comparison, if we have molecule having same nature, then we have to look at the size of the molecule. Bigger the size, lesser the number of vapors will be created at a given temperature, so it will exert lesser vapor pressure. The fourth point is the temperature. Same liquid at different temperature will have different vapor pressure. It means that temperature is proportional to vapor pressure. Let's suppose we have water at two different temperature. In one case, let's say water is placed at 25 degrees centigrade, and in other case water is taken at 50 degrees centigrade. So at high temperature, the rate of evaporation increases. The number of vapors will also increase. So more vapors will exert more pressure, and we say that vapor pressure of the liquid increase. So if we keep same liquid at different temperature, then the liquid at higher temperature will have greater vapor pressure as compared to the liquid having low temperature. There are so many liquids which has vapor pressure at in mmHg. Let's suppose we take some different liquids. The chloroform, which is a polar molecule, it have vapor pressure of 170 at 25 degrees centigrade. Similarly, carbon tetrachloride has a vapor pressure of 87 at 25 degrees centigrade, while water has a vapor pressure of 18 at 25 degrees centigrade. So if we compare the vapor pressure, we see that in water there is hydrogen bonding, which is stronger intermolecular forces. Because of the strong intermolecular forces, at same temperature, water will have less number of vapors and it will exert lesser pressure, or it will have low vapor pressure. So it is all about the vapor pressure. We will discuss the next topic, inshallah. So up till now, thank you and have a nice day.